All right, we're looking at inverse trig functions today. Evaluating inverse trig functions is what we're looking at today. So we need to do two things to prepare us for this lesson. First thing is I want to make sure we remember our special trig angles. Okay, what are our three special trig angles? What? What did you say?
30, 45, 60.
30, 45, and 60. Did I say 6 or did I say 3? I said 3. All right, just making sure. So we should know sine of 30, but what's 30 in radians? Pi over 6. Okay. Casey, what's an easy way to remember that 30 is pi over 6? Or how you remember it?
I just have it memorized.
You just have it memorized. Anybody else have a way they memorize or they know that 30 degrees is pi over 6? What's 60? Pi over what? Pi over 3. What's something that's going on between 30 and pi over 6 and 60 and pi over 3 that you notice? What? They kind of switch. The 30 and the 6, the 60 and the 3. So you never get a 30 and a 3 or a 60 and a 6. They always are switched. All right, so sine of pi over 6, cosine pi over 6, tangent pi over 6. So what are these three evaluated? Tell me what these three are. It's taking too long. We should be able to pop these out. What's sine of pi over 6? Do they know them? They're just scared of me?
Yes.
What are they?
It's just been a while since we've touched on them. We used them on the final, but that's the last time we talked about them.
Okay.
We've been talking about graphing tangent and cotangent the last 2 days.
What did you say?
3 over 2.
Which one's square root of 3 over 2?
Cosine.
Cosine square root of 3 over 2. Sine is 1/2. Okay, and if I know sine and cosine, what do I do to get tangent? Take the tops. So I have 1 over the square root of 3. What's the other way you might see 1 over square root of 3? Square root of 3 over 3. Good. Alright, so then we need sine of pi over 3, cosine of pi over 3, tangent pi over 3. Okay, and if I know these three, it should be super easy to get these three, because all I have to do is what? Switch what? Switch the cosine and the sine. So that means this is a square root of 3 over 2. This is 1/2, and that means tangent's what? Square root of 3. All right, so then we have sine, cosine, and tangent of 45. What's 45 as radians? Speak up. Pi over 4. And to me, this pi over 4 is the easiest one, because what do you know about sine and cosine? They're the same, and what are they both? Square root of 2 over 2. What's another way I might see the square root of 2 over 2? 1 over the square root of 2. Okay? And that means tangent has to be 1. Alright, when we evaluate inverse trig functions, it's very important that we have these either memorized or in front of us. Okay? You've got to be able to produce this stuff very quickly if you don't have it memorized. Okay? We have 9 items up here. Of these 9 items, in order to produce all 9 items, how many items do you need to know? If you know 3 of them, then you can get the other 9, is what you need to know. Okay, what 3 do you need to know? You need to know this one, and that one. Okay? Obviously, if I know sine and cosine, I'll automatically know tangent. And if I know all the pi over 6s, then I automatically know all the pi over 3s. And if I know sine, then I automatically know cosine, which means I automatically know tangent. Okay? So if you want to get away with memorizing the least amount possible, those are the 3 things you need to memorize. Okay, and you need to be able to produce all 9 of these very quickly. All right, good on that? Next thing we need to remember, is there a way to clear the whole screen? I've never used the smart software. Okay, thank you. All right, next thing is we need to remember some stuff about inverse functions. What do you guys remember about inverse functions? What can you tell me about inverse functions?
You switch Y and X.
Switch X and Y. That's a good start. What else? If I look at the graph of a function, how can I tell whether or not it has an inverse? You guys remember that? If I look at the graph of a function, how can I tell if it has an inverse? That's how you find one, is if you flip it over. But how can I tell just by looking at it whether or not it has an inverse function? Anybody remember that? It is the horizontal line test. Okay, if we pass the horizontal line test, then that means we have an inverse. If we don't pass the horizontal line test, that means we don't have an inverse. Okay? All right. So, we want to deal with inverse sine, inverse cosine, and inverse tangent. We're probably only going to get to inverse sine and inverse cosine today. Okay? And this is one of those things that it takes a lot of time to introduce, but once you get the hang of it, some of you are going to find that inverse trig is super easy. Okay? It's just up to you and how well you know your inverse or your trig, your special trig that we just wrote on the board. If you know that stuff well, then inverse trig is super easy. Okay, but again, like I said, it takes a while to introduce. So, all right, how did I just say we determine whether or not a function has an inverse? Horizontal line test by looking at its graph. So we want to throw up a graph of sine to get started. Okay, what do you guys remember about the graph of sine? Or what can you tell me about the graph of sine? It's a wave. Give me some points. If it's just straight up sine.
Starts at 0, 0.
Starts at 0, 0. There we go. Okay. What else? Say it again. Pi over 2, 1. So there's pi over 2. And we have 1. All right. What else?
The period's 2 pi.
Period's 2 pi. So there's pi over 2. There's pi. There's 3 pi over 2. There's 2 pi. So if I start at 0, that means I also have to end at 0. Okay. What else? What?
Yeah.
Oh, sorry. Thank you. So yes, pi is here. And then 3 pi over 2 is there.
Pi is on the line.
Pi is on the line, so we're 0. And then at 3 pi over 2, what happens?
Goes down to -1.
Goes down to -1. Okay, so I have this. And it continues on that direction. If I go this direction, what's my next spot? If I go to the left.
Down.
Say it again. Down, what would be my value here? Negative pi over 2 would be here. And then this spot would be negative pi. Okay, so we go here and we go this direction. All right, so there's a rough graph of sine. All right, so once I have a graph, what am I interested in? The horizontal line test. Does it pass the horizontal line test? No, it does not pass. Because if I draw a horizontal line, I'm going to touch that horizontal line more than once. Okay? So technically, sine does not have an inverse. But there are some situations where we need to deal with inverse sine. Okay? So what I want to do is I want to pick out just a window of sine where I have all the values from top to bottom that passes the horizontal line test. So can anybody pick out a window for me where I have all my values from top to bottom and I can pass the horizontal line test? Can you pick out a window for me?
Pi over 2
pi over 2 to what?
3 pi over 2.
Pi over 2 to 3 pi over 2. Okay, everybody like that? Does it pass the horizontal line test? Yes, it does. Does it have all of my y values, top to bottom? Yes, it does, but that's not the one we're going to pick. But it's very good. You answered my question. You picked out a spot. Okay? Anybody know another spot that I could pick out that would have top to bottom?
Pi over 2 to negative
Pi over 2 to negative pi over 2. We always want to start with the left side, so we're going to say negative pi over 2 to pi over 2. Okay? That window works as well. Has everything from top to bottom. And that window is the window that the math community uses. Okay? So they use negative pi over 2 to pi over 2. Okay, what is that called? Is that called domain or range? If I'm talking about negative pi over 2 to pi over 2. What is it? Domain. That's my domain. So I want to write that down. All right. And what else? When we usually talk about domain, what else do we talk about? Range. What would my range be? Very good. Well, actually, we're going to say negative 1 to 1. All right. So I'm only interested in that little window. So this piece right here. All right. So that's what we're interested in. When we deal with inverse sine, we're only dealing with that little window right there. Say it again.
Should be positive. Negative. It's okay. You said it, but I just don't want them to write that
it
down
happens.
wrong.
Thank you. All right, so there's the graph of sine. Now let's look at the graph of inverse sine. So this was the graph of sine. Now let's look at the graph of inverse sine. And that's what that little negative 1 up there stands for. It stands for inverse sine. All right, and Zadie, how did you say a function and its inverse were related? What do we do?
Switch X and Y.
Switch x and y's. So let's pick out some points from my graph of sine that we want to switch. So there's 3 points on the graph of sine that I want to pick out. What are those 3 points? 0, 0, pi over 2, 1, and negative pi over 2, 1. Now, I want you to notice something. When you switch the x and y, notice what happens. Okay? What type of values are on my x-axis for sine? The radians. And what does it represent? An angle is what I want to hear. Uh-oh. Okay. And on sine, what type of values are on the y-axis? Just numbers, okay? So now, what's going to be on my x-axis for inverse sine? The numbers, okay? And specifically, what numbers? Speak up. 1 and negative 1, okay? So I'm interested in negative 1 and 1. Notice, I had 1 and negative 1 on my y-axis, so that's what has to show up on my x-axis for the inverse, okay? On the x-axis for sine, we were interested in negative pi over 2, 0, and pi over 2, so that has to show up on what for its inverse? The y. So I've got to have negative pi over 2 here, and I've got to have pi over 2 there. Okay? So my 3 ordered pairs, what was this ordered pair? Negative pi over 2, negative 1, so what does it end up being over here? Negative 1, negative pi over 2. Very good. So that's right there. Okay, my middle point's pretty easy. This point is 0, 0, so it ends up being 0, 0 as well. All right, and this last point is pi over 2, 1, so it turns into 1 pi over 2. All right, now we need to know how to connect those 3 dots. We need to talk about the curve. And back here in the corner, you mentioned that when you graph the inverse, what do? The line y equals x. So I need to take it and reflect it over the line y equals x. So if I take it and do that, what happens to my curve between these 2 dots right here? Is it curved like this or is it curved under? It's curved under. So I need to draw that curve here. And then when I flip this section right here, it's curved under, so that means over there it needs to be curved over. All right. So there's the graph of inverse sine. Okay, I'm going to give you some free information. All right. To tell whether or not something had an inverse, we use what test? The horizontal line test. To tell whether or not something is a function, what test do you use? The vertical line test. Now, notice my curve is going like this along the x-axis. So if I continued right here, which way would my curve go? So if I kept going past this point right here, what would happen?
Back into the center.
It would come back this direction and go up, and down here it would go that direction. What would it fail?
Vertical line.
It would fail the vertical line test. So that's why you use the horizontal line test to determine whether or not you have an inverse. Because if it fails the horizontal line test, that means its inverse is going to fail the vertical line test. So that's why you use that. All right. So 3 important spots we need to identify over here are these 3 spots right here. Okay, we need to identify those. So what is this first ordered pair? -1, negative pi over 2, the middle spot, 0, 0, and then the right spot, 1 pi over 2. Okay. Now something else we want to do is write down our domain and range. Okay, what should happen to my domain and range when I go from sine to the inverse? They should switch. Good. So we should be -1 to 1. We should be negative pi over 2 to pi over 2. Very good. So the important stuff we need to know from the inverse sine graph are these 3 points right here, and we need to know the domain and range. That's the important stuff. All right, now we've laid all the groundwork. Now we can start evaluating inverse trig functions. All right, so you might see y equals inverse sine of square root of 3 over 2. Okay, that might be something you see. So before I talk to you about the answer to this, does anybody know what the answer to this thing is? Pi over what? Pi over 3 is my answer. How'd you get pi over 3? Okay. So, if you do regular sine, you would have seen this problem as that, and then we would evaluate it and got y equals square root of 3 over 2. Okay? If it's regular sine, what is our input? What are we inputting? What does pi over 3 represent? And radian measure of an angle. So I'm inputting an angle, and what did I get out? I just got a number out. Okay? And then again, Zadie, what did you say the relationship was between a function and its inverse? What's the relationship between a function and its inverse? What do we do? Switch the x and y. So if I'm inputting an angle and getting a number out, if I'm dealing with regular sine, what's going to happen when I'm dealing with inverse sine? What am I going to input? I'm going to input a number, and what's going to come out? An angle is going to come out. So if you notice, this right here is a number, and I got an angle out. Okay? So that's what you need to realize is you're looking at a number, and then you're asking yourself what angle goes with that number when you're dealing with sine. So that's why we wrote down all of those trig functions. Okay? So if I had, we wrote this down. Okay? So when I see this right here, I'm going to go on the right side, and I'm going to find out where square root of 3 over 2 and sine match up. And then whatever this is, that's going to be my answer. Okay, so that's how you need to think about evaluating an inverse trig function. Let's try another one. All right, so I have y equals inverse sine of 1/2. All right, somebody tell me what the answer to this is. What do you got?
Pi over 6.
Pi over 6. My answer is pi over 6. All right, how'd you get pi over 6?
Because it matches up with 1/2 on negative sign.
So I went and found sine, I went and found 1/2, I found that match, and then whatever that angle is, that's my answer. How do we feel about that? Okay, you're just pretty much playing the matching game. All right, what about this one? Okay, y equals inverse sine of 1. What is it?
3 pi over 2.
It's not 3 pi over 2.
Pi over 4.
It's not pi over 4.
Oh, it's pi over 2.
It's pi over 2. Okay? What you should notice is this one did not show up on your special angles. Okay? On those 9 we wrote down earlier, this one did not show up. If it does not show up on those 9, then that means it has to be one of these points right here. Okay? So we're looking for one of those points, and I'm looking for 1 on one of those points. So I've got -1, I've got 0, I've got 1, there's 1, so that means pi over 2 has to be my answer. So you guys did what I wanted you to do. You looked at those 9, it's not on there, so then we go to the ordered pairs, and then that's where you find your match. Got it? Okay, so another one you might get is y equals inverse sine of 0. You're not going to get a match on the 9, so then you go to the graph. What does the graph tell you the answer is? 0. So my answer would be 0. So I would get 0. Inverse sine of 0 is 0. How do we feel about that? All right? Okay, let's throw some negatives in there. So I have y equals inverse sine of negative square root of 2 over 2. Y equals inverse sine of negative square root of 2 over 2. Any thoughts on this one? 7 pi over 4 is an answer, but it's wrong. Okay? We've got a pretty good idea about it, but somebody tell me why 7 pi over 4 is not an acceptable answer. It's what? No, because sine of 7 pi over 4 does give me a negative square root of 2 over 2. But it's not an acceptable answer. Somebody tell me why it's not an acceptable answer.
Pi over 4 comes first.
5 pi over 4 comes first, but 5 pi over 4 is not an acceptable answer either. Somebody tell me why those two, they do produce a negative square root of 2 over 2, but they're not an acceptable answer. Look on the board. There's something on the board that tells me it's not an acceptable answer. What? You're using the wrong word. It's not in the range. Those two values are not in the range. Okay, if you look right here, that right there tells me what my answers have to be between. That tells me my answers have to be between negative pi over 2 and pi over 2. 7 pi over 4 is not between those, and 5 pi over 4 is not between those. So I've got to figure out what's an answer that gives me the negative square root of 2 over 2 that's in between those two values. Anybody know? All right, let's go to the graph. Maybe the graph will help me. Okay, negative square root of 2 over 2 square root of 2 over 2 is approximately 0.707. So if I put a negative on there, I'm going to go negative 0.707, which is right here. Okay, and that matches up with right here, that y value. Well, if I come over here, okay, that would match up with a y value that's right there. If I have 0 here and I have negative pi over 2 there, what value is going to be right here? Negative pi over 4. So my answer is going to be negative pi over 4. What does this graph tell me? Anytime what I'm putting in is negative, what does this graph tell me my answer has to be? It has to be negative, because this graph right here corresponds with y values that are right here. So anytime I have something that's negative, it's going to produce a negative. Okay? And that's what makes inverse sine super easy. Cosine's a little bit more difficult. Inverse sine is super easy. So if I throw another one up there, whoops, getting ahead of myself. So if I throw that up there, what's my answer to inverse sine of negative 1/2 going to be? It's negative pi over 6. So what you're going to do is you're going to use the positive 1/2 to find your match. So my match was pi over 6, and then the fact that it's negative in inverse sine tells me that my answer has to be negative. Okay? So again, anytime you got a negative inside of inverse sine, your answer has to be negative. Got it? All right, now, I'm pretty much done with inverse sine. There's one more thing I want to talk about. How many possible questions can they ask you about inverse sine? How many possible questions can be asked about inverse sine if you're going to do it by hand? Obviously, there are some situations where you can use it by calculator. But if they want you to do it from memory, how many answers or how many questions can they ask you? 6 is incorrect, but you're close.
7.
Nope. Nope.
12.
12 too many.
9.
What?
9.
9. Tell me why it's 9, Zadie. 9 of them? What do you mean 9 of them?
Like 9 different things.
Yeah, but those 9 different things deal with sine, cosine, and tangent. I'm only interested in sine right now.
But can't you get the other ones also?
You can, but I'm asking just specifically sine. How many questions can I ask you about sine? 9 is the correct answer, but your explanation's wrong.
You have the keys that you can memorize. You have the 3 points on the graph, and then you have 3 in between, I guess, the points on the graph.
You're close. I like what you're saying. Just anybody understand what he's saying and can clean it up for me?
Is it because there's like the pi over 4, there's 3 of those, and then there's 3 of the points and 3 of the degrees?
Nope. You guys have 2/3 of it. You guys have 2/3 of the explanation. Okay? So like you were saying, we've got sine of pi over 4. We've got sine of pi over 3. We've got sine of pi over 6. And then from the graph, we can do inverse sine of 0. We can do inverse sine of 1. We can do inverse sine of -1. So I've got 6 up here. So what are the 3 other ones that we're missing? No, you guys are making it super hard. Not the inverse. What did we just deal with? What did we just deal with on the last 2? The negatives. So we have the negatives of those. Okay, so we have these 3, we have these 3, and then the negatives of those. That's why you can only be asked 9 questions on inverse sine. Make sense? Follow me? Okay, so this was square root of 2 over 2. This was 1/2. Nope, this is 1/2. That's square root of 3 over 2. So I can only see this, that, and that, plus the negatives of those. Those are the only numbers that they can ask you about inverse sine. You guys follow me on that? If you see something else besides those 9 things, then you've got to use your calculator to get the answer. With me? Alright, so that's inverse sine. So, this number I'm going to match with my special trig stuff. If it doesn't match here, then my answer's got to be where? On the graph. It's got to be one of these 3 ordered pairs to get my answer. Okay? And if this number is negative, my answer is going to be negative. That's all there is to evaluating inverse sine. So how many of you think I can throw a problem up there and you can get it right? That's not good. So let's throw one up here and see if you can get it right. I want to evaluate inverse sine of negative square root of 3 over 2. I want to be able to get that. What did you say, Carly? Pi over 3. Negative. How many agree with negative pi over 3? Okay. How'd you get that, Carly?
Because the sine of pi over 3 is square root of 3 over 2.
Okay, and how'd you know my answer was negative?
Because the inverse is negative.
Because that's negative. Very good. Okay, inverse sine of negative 1. Negative pi over 2. Who gave me that answer? How'd you get it? It's on the graph. How'd you know to go to the graph? It wasn't on my special trig function. Very good. After doing those 2, how do you feel? Because if you can do these 2, then you can do all of inverse sine. We good? We ready to go to cosine? Because once we've done sine, we should be able to feed through cosine. Because now we know what we're looking for. So let's try that. All right, clear that for me, please.
You just hit this button right here.
Okay. All right, so what do we need to get started with if we're going to talk about inverse cosine? Graph of cosine. Good. All right, what can you tell me about the graph of cosine? Starts at the amplitude, so if it's just cosine and I'm not transitioning or translating it at all, what? Starts at 0, 1. So we're going to start at 0, 1. All right, give me something else.
Then it starts going down. It starts going down to the right part.
It starts going down to the right. Where does it hit the x-axis? What'd you say? Pi over 2. Okay, so I've got that, and then we bottom out at what?
Pi.
We bottom out at pi. Okay, so that's going to be at negative 1. That's going to be at 1. So we bottom out. Then we're back up to the x-axis at 3 pi over 2. So we're back here at 3 pi over 2. Okay, and then we go back to the top at 2 pi. So we're back up to the top at 2 pi, and then it'll continue on to the right. Okay, on the left, we go that direction. So, does cosine technically have an inverse? Why not? Doesn't pass the horizontal line test. But I want to be able to deal with inverse cosine, so what do we need to do to the graph of cosine? We need to limit it. We need to find a window. So what's a window that we like for cosine that gets everything from top to bottom and passes the horizontal line test?
1 period.
Not 1 period. 1 period, it'll fail.
Okay. Half a period.
Half a period. Give me more specific. Where am I going to start? Where am I going to stop?
0 and 3 pi.
0 and pi. So 0 and pi. Okay. So this section right here is what I'm interested in. It has all of my y values and it passes the horizontal line test. Okay. So that's the window we want to look at. Very good. All right. So we want the domain and range for this little window. Okay. So what's the domain for that window? Where does it start? Where does it stop? 0 to pi. Very good. Okay, then we want the range. What's the bottom? What's the top? -1, and the top is 1. So over here, when we get to the inverse, what do we know about the domain and range? They're switched. So we know the domain is -1 to 1, and we know the range is 0 to pi. Alright, so -1 to 1 and 0 to pi. I need to redraw this. Alright, so -1 to 1 and 0 to pi. Very good. Alright, what do we do next with sine? What do we do next? Graph the inverse. What did I do to help me graph the inverse? We picked out some points over here. So what are some points we're interested in over here? 0, 1. So if I have 0, 1 here, over there I have 1, 0. Okay, so I've got 1, 0. Next point.
0 over pi over 2.
Alright, pi over 2, 0. And over here it turns into
0 over
0 and pi over 2. So here's 0, pi over 2 has to be halfway in between 0 and pi. Alright, and my last point. What's my last point?
pi over -1.
Pi and -1. So over here it is -1 and pi. So I've got my 3 dots there. Now I just need to know how to connect them. So, this first section right here, if I flip it over the line y equals x, does the curve change? Because right now it's kind of got a curve that's on top. Would it change to a curve that's on the bottom, or is it going to stay on top when I flip it over the y equals x? It's not going to change. Because if I take that and flip it, it's just going to go right back on top of itself. Make sense?
Flip it which way?
If I take it and then turn it over,
Oh.
it's going to be right back on top of itself. Okay? So if I do that, so that means this curve right here is going to look like that. Okay? And then this other piece is what flips over here. So when I flip it over here, does the curve change? Is it still on the bottom, or does it flip over to the top whenever I do that? Can you guys visualize that?
No.
If I had this, if this was a sheet of paper, and then I took it and flipped it over, would the curve still look the same, or would it change? It would stay the same. So this piece right here and this piece right here still need to look the same. So it needs to look like that. So this piece right here just flipped on top of itself. This piece has to come all the way over here, and that's why it ends up here. Okay, so that's what my curve looks like. All right, now we've got everything we need to evaluate inverse cosine. Okay, and let's go ahead and write down these points right here. Okay, what is this point right here? That point is 1, 0. What is this point right here? 0 pi over 2. And this point right here? -1 pi. All right, now, sometimes instead of the cosine to the -1 or the sine to the -1, you might see something like this. Okay, you might see arc cosine. Arc cosine and inverse cosine, for our purposes, mean the same thing. So when you see that arc cosine, know that that's the same thing as inverse cosine. So, can anybody give me the answer to this one? Pi over 3. Very good. So my answer is pi over 3. How'd you get it? You found cosine and you found 1/2. You found that match, and then the missing piece was pi over 3. So that means pi over 3 is my answer. How do you feel about that? Good with that? Okay. So what if I have y equals arc cosine of 0? Arc cosine of 0. What is it? It is not 0. It's pi over 2. Okay, how'd you get pi over 2? The graph. Okay. So 0, I go to find a match. Can I find a match on my 9? No. So that means I need to go to the graph and find a 0. I need to find a 0. My 0 is right here. It matches up with pi over 2. Pi over 2 is my answer. Okay. Alright, I have y equals arc cosine of 1. What's my answer for y equals arc cosine of 1? 0. That one's 0. Okay, how did we get 0? We went to the graph. We don't have a match. We go to the graph. I'm looking for 1. I got negative 1. I got 0. There's my 1. So that means my answer is 0. All right. All right, what about arc cosine of negative square root of 2 over 2? Arc cosine of negative square root of 2 over 2. How much? Negative pi over 4 is the answer I was given. How many of you like negative pi over 4? And if you don't like it, tell me why. How many of you like it? How many of you don't like it? I should have people's hands raised on people that don't like it. Ms. Colson, why do you not like it?
Guys, look at the range. Can you have negative pi over 4?
No.
My range right here says my answers have to be between 0 and pi. Are there negative numbers between 0 and pi? No. So Casey, what did you say it is? 3 pi over 4 is correct. Now, how'd you know it was 3 pi over 4 versus 5 pi over 4? It has to stay in the range. 5 pi over 4 is not in my range. And again, with the negative piece, we can go back to the graph. Okay? So negatives are right here. So the negatives match up with this part of the graph. Okay? So all of my answers right here have to be between pi over 2 and pi. If you go to the unit circle, what quadrant are you in if you're between pi over 2 and pi? 2. You're in quadrant 2. So that means if I'm dealing with inverse cosine and I have a negative, then that means my answer has to come from where? Quadrant 2. Okay? So, that's what I'm getting if I'm dealing with pi over 4. If I'm dealing with pi over 3, what's my answer for pi over 3 in quadrant 2? Look at your unit circle. What's the answer for pi over 3 in quadrant 2? What is it? 2 pi over 3. Okay, and then what about pi over 6? What's my answer? 5 pi over 6. What do you notice about the numerators of all three of those answers in relationship to the denominators? They are 1 less. So anytime you're dealing with inverse cosine and you have a negative, you know that the top has to be 1 less than the bottom. Got it? So let's try another one. So let's do y equals inverse cosine negative square root of 3 over 2. So my thought process is I get my match first. So what's my match for square root of 3 over 2 and cosine? Pi over 6 is my match. And then because I see a negative in inverse cosine, that tells me that my top number has to be 5. Because it has to be 1 less than the bottom. Okay, that's the main difference between inverse sine and inverse cosine. If I'm dealing with inverse sine and there's a negative inside, what do I do to my answer? I just make it negative. But if I'm dealing with inverse cosine and I have a negative inside, what do I do with my answer? The top needs to be 1 less than the bottom. That's the difference between inverse sine and inverse cosine. Okay? One more problem. All right.
The range is the same size, so that doesn't go into the negative.
It's the same. The range is the same size. It just doesn't cover the same area. Yes. So what's my answer for inverse cosine of -1? Pi is my answer. Because when you look for a match, did you find a match? No. If you don't find a match, then that means it's got to be on the graph. Here's -1. There's pi. Okay? How many questions can I ask you about inverse cosine? 9. I can ask you 9 questions about inverse cosine. How many questions can I ask you about inverse sine?
Teachers and students, please pardon this interruption. A quick announcement. Orchestra students, you need to meet the bus following third hour outside the front doors. All orchestra students going to Soldier Creek 2. For today, you need to meet your bus outside the main front doors immediately following third hour. They will not wait very long. And also, if you have Mr. Little for ag classes, please listen up. Second hour ag classes, you're going to meet in Miss Bryant's room, B242. Third hour ag classes, you're going to meet in Coach Ayler's room, B149. Fourth hour ag classes will meet in the vocal music room with Mr. McIntosh. Fifth hour in room C258 with Mrs. Colson. And finally, sixth hour ag classes, room A117 with Coach Price. Thank you so much.
All right, so here's your homework assignment. Your homework assignment is to write down the 9 questions you can be asked about inverse sine and write down the 9 questions you can be asked about inverse cosine. That's your homework assignment. The 9 questions you can be asked about inverse sine, the 9 questions you can be asked about inverse cosine.